What's up, everybody? How's it going? So, numerous projects on the table here. This is our latest six magnet gyroscope, 6 coils. The coil base can spin either direction, rotor can spin either direction at the same time, but it's tethered down right now. So, what are we going to do about the tether? We need to talk about that. But before we get on into that, we're gonna take it easy, slow up. I'm gonna turn this on just to see. See now, there's 1,111 turns of 32 gauge copper in each one of these coils. There's 6 coils. So how many turns altogether? 6,666 turns altogether of copper in this system. And 6 magnets. Three of the coils are hooked up right now at 120 degrees. But as you can see, I'll put it here. It'll work. I can move it around. It'll continue to work. And then I can put it on this one, which is right next to it, and it'll work. Because they're timed like perfectly, I can put it on this side of any one of these coils and it'll spin to the right. I put it on the left side. Watch this. We're only drawing 100 milliamps doing this too.
Oh wow, it stopped it and it pushed it.
Yeah. So if you do on the left side, it'll go left. It'll go left on all of them. It's uniform, and it doesn't really matter which one you put it on. Is what I'm getting at. And then when it's not tethered down, how are we gonna make it so it's not tethered down? See, just to run it, I gotta have wires hooked up to it and everything, right? No, we're not gonna do that. I have coming in the mail copper that I'm gonna make 2 copper rings that are one inside the other, right around the shaft. So let me stop playing with this for a second. Turn it off. Let me show you where I'm going to put the commutator, the 2 commutator rings, which they're going to be rings because we want the power to stay on constantly. Okay, because I'm going to run it with the reed switch. I'm not going to use the commutator to pulse. I'm just using it to connect the mechanism to the power supply without having it be tethered. It's a prototype of a gyroscope.
Except people just shot in right after that.
Yeah, check it out. All right.
Look at this.
Okay, so this, I'm gonna get a toroid and put it right here, and then I'm gonna have a copper ring on top of that, and then I'm gonna have another ring on the outside of that. So I mean, I wish I could like. All right, so yeah, that'll work. You got your roll of tape. That's going to be your toroid magnet like this. Then you got your first copper ring. That'll go right on top of the toroid, like so. It'll be a lot shorter than that. It won't be stacked that high, but that's the general idea. And then you have another one on the outside of that, because you need two separate contact points. You need a positive and a negative contact point that aren't touching. And then I'll basically have something very limber hang down for each wire, because they'll all be in series, I'm pretty sure. Series circuit. So it'll be a positive and a negative. This is a toy, by the way. This is a tabletop toy. This is a prototype for. I might make a bigger one if this one works. All this. Hell yeah.
And this is all 3D printed.
Yeah. This was 30% infill on honeycomb. This is solid as a rock, man. It's not that heavy, but it's solid. So when I get the toroid, there'll be one on the bottom here, just like there's one on the top on the inside. And you'll get some maglev right there. And you got your maglev in the center. Like this, you got your maglev. And that'll spin like a gem. This will start to be able to spin like a gem. I mean, it will spin right now. It's got clips on it. Let me take those off. Because it'll spin right now. It just needs a maglev to spin well. And then I'll shorten up the things. I got single wire connectors coming. All right, here we go.
Hey, Jacob.
Hey, what's up, Jacob? This is a prototype to try. I'm just trying to make a gyroscope. So this one will spin this way, and this one will spin this way. And I was just discussing how I would use commutator rings on the bottom to make it so I could use power and have them both spin.
Hey, everybody. Welcome to the channel. Like and subscribe. Drop a comment if you were wondering what we're doing. And thinking about joining with a membership. It's the best way to support the channel right now.
Amen. Thank you.
Hey, Roy. How's it going?
Hey, Roy.
We are in Metro Detroit.
How we doing? I'll let you decide. So right now we have the toroid on the bottom of the rotor and the top of the base, or the top of the gyroscope piece. Top of this. Okay? So we're going to get one on the bottom of this. We're going to get one on the top of the base. So it's just floating there. Right now it's making contact with the base, which is slowing it down tremendously. Yes. It's not going to gyro right now. It'll run as a motor because it's not I don't have my commutator built yet, so it's not gonna spin both ways.
Jacob said we had those in some of the aircraft avionics I used to work with.
Gyroscopes?
Yeah, and he said, cool to see the inside.
Oh, I haven't even looked at a design. I just, well, actually one, a 0-point force motor or craft from OCT something. Very cool article. And I just, from that picture, this is what I gathered from it. And then I tried to piece all, problems, bumps you'd find in the road. Like the commutator issue. You can't have this thing spin because it because the wires are tethering it down. So how do we get that out of the way? Why don't we just turn it all the way up? Oh, I'm gonna have to turn that down now.
Jacob said this is without schematics. That's excellent.
Thanks, Jacob. See, and once we get the commutator in play, and I just glue this reed switch right to the side of this coil and throw it that way, and it should take off, kind of. And if I'm missing something, we're going to find out what it is along the way. That's just how I do business. I know it takes a lot of time, but I have a lot of time.
Thanks for the likes, everybody.
Really appreciate it. Originally, this was supposed to have 12 coils in my original thought process, but then I'm like, that's going to be cluttered for something this small. I could still do it too. I mean, I have the spaces already made out. It'll fit. It just, it'll be, my fingers aren't that nimble. This was nice and comfortable. And then this right here, I mean, this is part of it. So we'll have a toroid magnet on the top of the rotor. I will double stack the one in the middle here. And we'll have one on the top. And we'll have one in here. And we'll put this on here like this, and through repulsion, it should go right back down into what its position, where it's supposed to be. And then I would, unfortunately, once I get to the point where I feel like it's good, I heard that the odd numbers are bad for this particular build. I love using 9 magnets. All my other rotors basically have 9 magnets on them. Oh, but you meant 9 coils.
Yeah.
9 coils. I could try that. Right now we're just using 6.
That would be a 40 degree.
Yep, 40 degrees. And then let me think here. 30 degrees for 12.
Yeah.
And I could do 12. It's not a problem. Well, really, I mean, it won't be too bad. And yeah, to do 9 at this point, I would basically have to make another one. But for the big one that I'm going to make, I might try that with 9. But I can easily do 12 on the big one, so I don't know.
Jacob asks if there's any plans for practical applications.
If I can get it to work, maybe. I'd have to think about it. I don't even know what it's capable of doing at the moment, honestly. I heard it can go really, really fast if you build it right.
And Beat said, "Cool. I keep blowing up reed switches."
Oh, hell yeah, man. Reed switches are real touchy. This one, the light, the indicator light on the end of it, showing you that it's working, it blows out all the time. It comes back on, it'll blow out. These, by the way, are CS1-F. Very good reed switches. High frequency. These don't burn out because it's going fast. They burn out because of like too much voltage going into them, or spikes, or whatever kind of voltage is going through them. See, there it goes. Indicator light is on.
Right on, Jacob. Yeah.
And I mean, just it starting up forces the coils that way. The rotor's going that way, and the repulsion aspect forces the coils that way. And when the maglev is here in the commutator, they'll actually be able to move that way. Maybe even start to spin that way. So you can see it. Did you see it jerk or start moving that way? Yeah, when I move it in there, it starts to move.
Oh, yeah, you can hear it speeding up.
It wants to go that way. The coils do.
Okay.
You see it.
But they're tethered in.
Yeah, they're tethered in.
Okay.
That's the whole problem. They're tethered in, and there's contact with the flange on the base and the bearing. They're touching each other, so there's lots of friction there. So, yeah, I mean, I did some readings on these little coils. They generate about 1.1 volts. It was really weird, and somebody commented on this. There was a 6-volt reading on the meter, but the clips were on the ground, and everybody could see it. And he's like, "Where'd that 6-volt reading come from?" And I was thinking the same thing. Where did that 6-volt reading come from?
Yeah.
Thanks, Jacob. So I'm gonna try the commutator. It'll probably be 2 days before I get that done because it's got to get here, and then I got to make the design. Because I just came up with, how am I gonna do it? What am I gonna make it with? How's it gonna work? And then I'm like, well, what does it have to do? They can't be touching, and the contact's got to be continuous, and it's got to be conductive. So I got copper plating coming. Gonna make the 2 rings that aren't touching each other, one inside the other. And then I'm gonna have like something just hanging down like this, but with slack, so it's like that. Get it? And have it just drag. That would be stiff enough that it's not gonna, fly with the force, and then just drag it along the ring. So you have a continuous contact. The front of the coils. Yeah, I was thinking about that. I was actually thinking about it'll be right around that general plane that they'll be connected, because I only need I can see doing that if I used if each coil had its own connection. And even then, well, I don't know. I think that might work actually. Have it be connected to the front of the coil, and then have the wire come out to here on each coil, and have it power linked via a ring like this around around the outside. See, now my ideas are just going through the roof.
What's up, Mike?
Hi, Mike.
And then Jacob asked any cooling.
I don't no thoughts of cooling at the moment. I am still, honestly, I'm skeptical. I would love to see it work, I'm gonna try. These are just ideas that I'm gonna try. I tried wires earlier today with paper clips. So I have my paper clips out. I put 2 paper clips on the wheel here, and I spun it, and then I had 2 wires coming down like this, but they were different lengths. So like the positive would hit up here, and the negative would hit down here, and they would never, and then it would be enameled on this one right here. So when it dragged across the second time, it wouldn't trigger it, or the positive would never be connected to the negative, kind of thing. I don't know if that's right. That's what I did. And it didn't work anyway. So I'm like, oh man, what's wrong with it? Hey, thanks, Pete. But yeah, I can definitely see that if each one of these coils was to fire on its own, from the power supply via one reed switch, that's how I would do it. I would have a ring of power, basically, that all these commutators would make contact with, I guess, right? But I'd rather just put it in a series. I have the one contact for each positive and negative.
Hey everybody, welcome to the channel.
Hey, what's up? So these are generator coils. You want me to figure out the Bedini half of this thing? Yeah, we're gonna do 12. I mean, oh, 6. 6. We're good. I got it figured out for this, and then I can upscale on my own. All right, Mike. I'll see you later, man. Thank you. All right, so we've seen it work. I kind of want to, well, we've seen it be a motor, basically. I kind of want to get to spinning this thing. See, look at those coils just go. Oh. Yeah, I got to make those ends a little shorter. They're getting caught. I can feel it.
Yeah, Jacob mentioned that the smaller scale is harder sometimes.
Yeah, absolutely, man. I'm only generating literally like 1.1 volts on one of these coils. That's why I put all 6 together. And when I put them all together in a drive, I can go up to 25 volts and not draw 100 milliamps at all. It's like very low on the amp requirements. I can't wait till the magnets get here. I'm excited.
Alright, Mike did post some stuff and he's back to his channel.
Okay, for example, 3 drive coils triggered like so on 360. He didn't know that I wasn't using the commutator to trigger.
There was one more ago.
The commutator to run the drive coils independently from each other. in regards to the timing. Yeah, I know. I'm not trying to use the commutator to trigger though.
Okay.
I'm just trying to use it to untether.
Got it.
See you later.
Could you use contacts that don't spin, like spinning the drive coils to the power from Jacob?
I don't know what that is. Yeah, the contacts won't be spinning. Well, either it's going to be stationary on the part that moves, or it's going to be stationary. Uh, I can't wrap my head around that right now. I don't know. Could you re-ask the question, Jacob? But, I mean, what Mike was saying is that maybe I could use the commutator, but you do realize, I think, what his design is going to have this shaft have to spin. And the shaft is fixed, so that isn't going to work. Well, I mean, on a larger scale, I could probably just spin these like that, and it would be enough to get it to go if I set it up right. The wiring. But with its size and it right now, it's not going to be able to generate enough. Because you see, when I turned it on to 24 volts. And then it would, it doesn't have to be that high, but you need like 10 to get it to move. I'm going to put 2 rings on the bottom, one inside the other one. One's going to be a negative contact point, one's going to be a positive contact point. I'm going to link these coils together in series. So I have one wire per point for right now. Because this is a toy. I mean, I'm going to take all your ideas and I'm going to put them in I'm going to utilize everything that I've learned from this to make a bigger one. But this is just a toy. So a ring commutator, is that what I'm talking about? The ring on the bottom? Oh, that's what he's talking about. Thanks, Pete. Thank you. I got confused. But Jacob, what he's saying, you're explaining what he's saying. I get it. My bad. Yeah. If I was going to do each one individually, like parallel circuit, that's how I would run it. Absolutely. And it would have a if I'm going to use the commutator to trigger the coils, then I won't need the reed switches, which I had in my plan. And then you just affix a reed switch. And if I did it in parallel, put a reed switch on the side of each one of these coils. But, in series, you just put one. Bam. Oh. I know how I feel. I know all about it. Thank you.
I think your kids are actually doing the dishes right now.
Yeah. I hope they're done with that. doing a great job. So, is this just a speedometer knob or is this a pot? I think it's a pot, honestly. Potentiometer, variable resistance. But yeah, this thing when it's done should spin like a top. I mean, look at those bearings. That is like greasy good. Should like I'll be able. It's not perfectly lined up. You see, it's not perfect, but I mean, like it'll be good enough. And then it should spin like a top. And then this should go the other way. When you get your reed switch on there, your series circuit, your maglevs, and your commutators. And will it fly? I have no idea. I don't know. I've never seen even a model, physical model of this ever, like, anywhere. I've looked. Not very hard, but I've looked. I've seen one drawing of it. And I guess it's in people's imaginations, UFO, flying saucer kind of thing. I guess this is what they decided was in it. Inside that thing.
Jacob said, I was thinking capacitors on each drive coil that spin and hit stationary power contacts. Caps deliver constant power, question mark?
Yeah, I was thinking a similar thing. I even have, little caps that I was going to use for that. But I know. Well, I don't know, actually. We'll have to see. There's lots of things I'm going to try. I will definitely earmark that idea. It sounds like a great thing to try. But right now, it's fair game right now. I mean, we got a frame. That's what we got. We got no wiring done whatsoever. We just got the frame and the rotor. And I'll finish the frame tonight with the rest of the toroid magnets. I'll glue it together. And we're going to have some like sandwich action going on with the rotor here. Because see how it's perfectly lined up right now? Perfectly lined up right now with the coils. But I was thinking about stacking one more toroid on that one and then putting this back on there and then putting a toroid on this one because there's only like 2 millimeters of clearance right there, and it's enough. But if it gets going, if it gets going really fast, it's gonna go this way, not that way.
You use grease or graphite for the bearings?
Oh, only graphite. And I haven't used any lubricant thusly. But this is the graphite that I use.
Thanks for the like.
Thank you. Alright. That little demon is a devil. No, I'm just kidding. This is going to be so much fun. And the thing is, you have to be spinning it at 24 volts of power speed-wise to get 1.1 volts out of it. I mean, if you put them all together, if you use all 6 of these coils and you spin them together, you can get maybe 10 or 11 volts in this style of build. Maybe we should look at that. Maybe we should look at that series circuit. Just we'll hook the multimeter up after we hook this up. Let's see how quickly I can do this. I'm getting good at doing this, actually. But there we go. Not bad. So what we're going to do is we're going to hook them all up into the power. They're all going to be drive coils. But we're going to get readings on that. Good readings. Now, I know this might bug a few people, but I gotta test each coil as I add it because my connections are bad. My clips are old. So we're only gonna like turn it up to 10 or something. Just try and get a response. If we get a response, we keep the clip. If we don't, we got it. All right. Now I got 1-to-1 connectors coming. So I'm going to shorten the length of the connections, or the leads, the ends of the coils, and just connect them. Oh man, my fingers are greasy. Okay. And they're all, these coils are legitly all facing the same direction. There's an in and an out to each one, and they're all the same. They're all wound the same direction. They all have the same amount of turns. Good so far. I don't want to mess with that. Oh, I put them up here. Yeah. Whoa. You okay?
Yeah.
God dang, you alright?
Yep.
Okay. Alright, need both hands, senor. beginning is marked with tape. The end naturally doesn't have tape on it. And we're going to say that the tape part is positive and the non-tape part is negative. It's like, why does north have to be north for real? So everybody can communicate. That's why north has to be north, because even though it's not really, um, I do have some white lithium grease. Alright. Too much. Could you help me with that, bro?
Well, yeah, is lithium grease non-conductive?
I have no idea. That's all
Wasn't
they have.
asking you, bro.
Oh. Nice. It's running so smooth, too. Yeah, I mean, the best way, I will look over all these comments, and the best way to get your ideas across is to get the Discord.
Electrical insulator is non-conductive. Okay, yeah, we're learning stuff still.
As long as it fits within the parameters of the shape and the parameters of this build, I'm going to give it a shot. And it should. Contact points for each coil.
He's like, lithium grease is not great to get on you. Don't eat it.
Literally, this is so good. And then we're down. We just got one more to go after this, and then I'll hook up the multimeter. Looks good.
Mm-hmm.
Drawing like no current on this.
Oh no. Had a A&P mechanic buddy take a bath in hydraulic oil and lithium grease by accident.
Oi.
No.
Yeah, that white grease is. Well, I guess it comes in different colors, but.
Mm-hmm. That's very unfortunate.
Yeah, man, that's it's a bad one. Bad accident. because somebody alluded me to the fact that drive coils are generator coils as well. And they're right, absolutely right. So they're all going to be drive coils. They're all going to be generator coils as well.
Hello from Serbia,
Hi. How we doing?
Christian.
How we doing, Christian?
Straight hydraulic fuel fluid will make your hands baby smooth.
So it's a good thing? Or do you want not baby smooth hands? I don't know.
He said it helped.
Okay.
Helped when we were woodworking, shipping braces for the engines.
All right. So. And jack it all the way up. Then, like the Warlock, we're just going to drop you. All right, so we're at 13 volts, 14, 16. This is a 6 coil series circuit. We're drawing like no amps at all. But that's at 24 volts. You gotta get the volts, bro.
Okay. Yep.
See, no amps are being drawn. Less than 100 milliamps. And now the power is not being pulsed through right now. We got about 7 volts going through it. This is what's left over.
So Pete said, definitely going to build a maglev into mine. The zero force point is a real thing, in my opinion.
Yeah.
It's the 0 point between minus and positive 12 volts where the magic happens.
So the Utrons are like 2 pyramids with the bottoms touching each other. Is that what they are shaped like?
Coffee time. All right. And yeah, don't pay a guy $15 an hour to ship millions of dollars worth of stuff. All right.
Are you talking? Yeah, no shnikes, man. That's for real. Because you're either not gonna get it sometimes, or it's gonna be broken, or gonna ship it to somebody else. He's gonna crop dust the wrong field, dude.
Oh, man.
But the reed switch. See, all of the circuitry all together, and the commutator thing, I'm gonna really consider like having the ring go around here, and have them both all hit at the same time because they're all timed the same way. That makes sense? You're welcome, B. Um, yeah. Have the capacitor. So this is what I'm like thinking now is that I have these coil. Each one of these coils be like a generator coil, and then I have a capacitor. But then I have a coil on the offset, which will be a drive coil or a pickup coil, basically, for this coil, which will have a diode. All this stuff has got to fit in this little case. You know what I'm saying? All the ideas for this one, but as soon as like it's all coming in the mail, I promise.
Jacob said, gave an example. They shipped it to Tonga instead of Spain.
Oy.
Exactly. That's a big one. That's a big crop dust mess.
Oh yeah, had a little bit of trouble getting that one back. I don't know. Let's see here. Oh. Something was stuck for a second.
Yeah, he said $20,000 in fees from that mistake. Holy smokes.
Oh, that is a little off. But it's impossible to center these ones because I don't have a ring that small to center them with. Maybe I could. I don't know. I'm gonna have to switch that up before we glue it all down.
Maybe print one?
Print a magnet?
A ring. Ring to center.
Oh yeah. I just love how like greasy it is, smooth it is.
Hey everybody, welcome to the channel.
Hey, what's up?
Like and subscribe, drop a comment if you're curious to what we're doing, and think about joining the membership. We're looking to collaborate with you guys and build together.
At this point, Bear, the shaft is fixed. It's glued in there. So
Oh, is that to the bearings in the shaft?
yeah, I think.
Okay.
I got ball bearings around the shaft, but the shaft is fixed. Like fixed. It doesn't spin.
Right on, Jacob.
Straight up.
Thank you for representing.
But look at this. Look at these bearings. These are true bearings right here. That will take like nothing to make it spin. There's no weight on it. Yeah, they're all around the shaft, man. Bearings right there, they go around the shaft. Bearings right there, they go around the shaft too. We got that covered, I'm pretty sure. Now I know what you're thinking, that in order to use a commutator correctly, I need to have a shaft that moves. We're not trying to use a commutator correctly. Trying to use it indirectly and incorrectly so that I can, now I'm definitely thinking about having the ring or two rings. See, each commutator for each coil, if you're going to do it like that, has to have a positive and a negative connection, because we need a constant flow of power not just pulsing power from the commutator. Our commutator power is going to be constant, not pulsing. We're not going to have any grooves. We're not going to have any separations in our commutator. And then we're going to use these.
Well, that's a great question. Let me get that close up.
Nobody is powering it with this anyway. A car maybe if it has a brain
Sorry.
of some kind. But I mean, if this thing takes off, it's gonna go until it crashes. Which, you know, I don't think it's going to take off because I'm going to put a flange right here on the cap. I'm going to put a stopper right here. So if it does decide to fly, it's not going anywhere.
Hey, Bubble Wrap.
Hey, what's up, Bubble Wrap? Nice. Thanks, man. What kind of ring? If it's a magnet ring, that's exactly what I'm doing. Just spinning it with my finger, I can get 3 volts. Almost 4. That's awesome, but that's spinning the opposite direction that it usually goes. Spin it the other way. No, we might have been going the wrong way the whole time.
Pete says a shim commutator, 2 different metals.
I don't know.
That sound yeah. That sounds like it would fit that description.
I don't.
Was a vacuum causing under negative pressure? Any plans for that? Right. Okay.
I do actually have a vacuum container. I'd have to saw this off, but I could put that in there. And no, I don't have any plans for any of this stuff. I've never seen a working model of this thing anywhere. I've seen a drawing in one place, and that's what I made this off of. So I don't know. I mean, it said in the one piece of information that I read, it said do your homework, and then I looked for more information on this thing, and I found nothing. And it was really like, oh my God, the feds are coming to get me kind of stuff. I was looking for like a build manual, maybe even a schematic or something like that, and it's not that. It wasn't that, and I was disappointed. But I do realize that this is very touchy stuff, especially if it works. You get a working model of this stuff, everybody would want that. I mean, and I'm not talking theory. We're going to do that here. We're doing theory here.
Bubble Wrap asked for a summary, a recap.
Oh, recap? Okay, we got a 6 magnet rotor. These are N52 magnets. This is a gyroscope setup, which is currently tethered. We're talking about commutators and how we're going to untether the coils. The coils spin. The rotor spins. Okay? It will spin freely if not tethered. So we're trying to get trying to get a commutator that'll work constantly. We're not trying to pulse with the commutator. We're going to use the reed switches to do the pulsing. Does that make sense? So the commutator is going to be a constant contact. There aren't going to be any bumps, any grooves, nothing like that. Just a solid ring. Because the power that needs to be sent up there, and then this is going to pulse the power. The reed switch is going to pulse the power. Make sense? No? Good.
Oh, BLS dropped in
Hey, BLS?
with a comment. That's a nice one. More magnets.
Yeah, amen. I love magnets. Magnets. Oh, we're drawing amps now. Oh yeah. So 100 milliamps. And when you glue the reed switch, see, I'm going to shorten up this cable, this cord right here. I'm going to shorten it up so it'll be applicable to the situation. And I think the actual positive connection is going to be on the reed switch. It'll be dropped down from the reed switch. Okay? And then the negative of the reed switch will hook to the coil.
Yeah, and the magnets on the outside, the reed switch is more responsive.
So now that we're almost done building our toy. You get it? This isn't the thing that's going to fly away. Okay, this isn't the thing. This isn't it. This is a prototype of a toy that looks like what I'm going to build. And I decided to do a step-by-step, maybe a build video here and there, show you what I'm doing. So all these ideas I'm going to keep in the vault for the next build. Because we're just trying to get this to gyroscope. And this is, we're going to work it with a series circuit. Because, oh no, actually you're right, man. We're going to do coil. What I mean is we're going to use the reed switches. We're going to have each coil have an individual attached to the commutator ring. We're going to try and do this with one connection, like a standard toy. You know, you buy it at the store, you plug it in with your AC adapter, and you're good. That's what it should be like. Oh man, this is great.
Yeah, this is a nice design.
And we'll put a few on-off switches in there.
Mhm.
So, I mean, so the reed switch positive connection would touch the positive ring, which would be connected with one clip to the power supply. And then the negative ring, with the end of the coil, would be connected to the negative ring. I'm probably going to need to get some solder gun happening to make that right, especially with 32 gauge. And then they're just going to drag along the ring. A loose connection.
So I have a thought.
Yes.
We go for about another 25 minutes,
Okay.
and then we come on prime time this evening and do another live.
Sounds good. All right. So I'm hoping that the mail has arrived, honestly. I'm going to check my computer in a second. Oops. Didn't really go like that. Yeah. So this wasn't done perfectly, and that's okay though, because it's not the way it is. It's not going to get in the way. We'll suck the air out of this vacuum, and you will know what it's like to be in space.
Boom.
You think so? Why is it going to be dangerous? If it's dangerous, I don't want to do it. So I need to know why it's going to be dangerous. Because the magnet might blow up due to heat. Is that what it is?
Yeah.
Yeah, no, that's what I want. I want a free spinning, fast moving light contraption. But I don't know. I mean, we'll have to see what happens when I hook the commutator up. I'm right now. I'm like 65, 35 that it's gonna work. It's gonna work. We're gonna get it right. We're gonna get the right connector. Everything's gonna be connected right, and it'll work. But the mag lab's gotta come, or this thing will not work. Because the rotor has a mag lab. So you need a mag lab for the other part too, or it'll never sync. Yeah, let me show you. This is my vacuum pump. I can't find my ceramic or my looks like some you bake like cook a turkey in rotisserie style.
That's right. Open up a portal.
We need Chris Cornell to do that.
Oh, yes.
This thing, or what it's
Um,
supposed to be.
he was talking about the vacuum.
Oh, the vacuum pump.
Yeah.
Yeah. Oh man, I can't even think about where I put it.
See, you were ahead of your time. You got all this stuff, what, like 15 months ago?
Yeah.
And now it's coming right into to your learning.
I could definitely buy another chamber and maybe even get one that fit right on top.
Mm-hmm.
All right, so I'm going to do one more demonstration with the cap on this time. And then this is it running at 24 volts right here.
Beam me up, Scotty. And then show the on the other side of the coil too. I think that's cool.
Heck yeah. And we're barely drawing 100 milliamps with this.
And that's putting the switch, the reed switch from one side of the coil into the other. So that's a great example of fields and in work. Ooh, LED on the inside would be fun. It wouldn't help functionally, but the aesthetics.
Oh, we got self lighting, like little lights. Where did it go? There it is.
Oh yeah. Oh yeah, that's right, little pushers. Oh wow. Yeah. We'll do that. We'll do that on the evening. Try to get it dark up in here, and then do that.
See, and if I didn't think this thing couldn't work, I wouldn't play with it. I think it can work. I don't think anybody's ever actually gotten it to work. Or, and they get to the point where it's either going to work or it's not, and it doesn't, and then they just hide. And they blame it on the government. I don't know. I have no idea. I think it's so weird that the government would find this interesting. And from what I hear, I don't know. I don't know. Because, I mean, the one guy that was a journalist and he was in Russia and then he got thrown in prison forever. I don't understand. I think he took pictures he wasn't supposed to take.
Jacob's kid says that fan looks funny.
Oh man. So, I guess what my next step would be, if we're gonna do solo coils, parallel coil doing here, is to get one coil to run while the thing is spinning, or the coils are spinning. Just one. Get the rotor to run one way and then the coils to spin as well. We need rotation with the coils. That's why I need maglev. So, because it wants to spin this way when you jolt it with 24 volts, it wants to spin this way. When the rotor spins this way, it wants to. And it's like, but it's tethered, so it doesn't.
Where did he go?
See, if that happens, everybody's going to know my name. I think it happened because everybody does. Or my initials anyway.
A local high school. No.
Mm. Yeah, man. Da-na-na-na. All right. That's about all I got for right now. I can't wait for my stuff to get here so that I can try out some of these wonderful ideas. Thank you very much. Peace out. Please subscribe. Have a wonderful day. Join. Bye bye.